This is number 5 on page 40. An engineer is designing a runway for an airport. Several planes will use the runway, and the engineer must design it so that it is long enough for the largest planes to become airborne before the runway ends. If the largest plane accelerates at 3.3 meters per second and has a takeoff speed of 88 meters per second, then what is the minimum allowed length for the runway? As always, we start by setting up our problem. So, I know dealing with kinematics, S equals xi plus vit plus 1 half at squared, and a equals vf minus vi over t. And then I'm going to set up my variables. So, s, xi, vi, vf, a, and t. Okay, so then let's draw a quick picture just to get our frame of reference squared away in our heads. Remember, terrible at drawing, so let's do a box. That's a plane going down a runway, and this runway has to be a certain length. We don't know what that length is. So we know that the plane is going to accelerate at 3.3 meters per second squared, and it has to reach an acceleration, a final velocity of 88.0 meters per second. How do I know that's a final velocity? Well, it's saying it has to get up to this velocity. So I know it's not my initial, it's got to be my final. Those are my only two options. So let's plug those numbers in. So 3.3 meters per second, and velocity final, 88 meters per second. That's all the information that I'm given. So I can make some assumptions here. I can assume that if the plane needs to reach up to that point, it's starting from a speed of 0. So I can assume vi is 0 meters per second. And xi, I'm the one who gets to set my frame of reference. So I'm saying right here, where the plane starts, that's my 0. Anything going that way is positive. So I'm missing time, and I'm missing displacement. So I can solve for time using this equation. Well, how do I do that? Well, I just have to do some simple rearrangement. So A equals VF minus VI over T. Well, if I want to get T by itself, first I need to move it from under and get it to the other side. So I'm going to go AT equals VF minus VI. So I've multiplied both sides by T. T over here cancels itself out. T over here just goes together. So AT equals VF minus VI. Well, now I need to get the T by itself. So I'm going to divide by acceleration. My A's cancel out, and I'm left with T equals VF minus VI over A. Substituting my numbers in, I'm going to have 88 minus 0 over 3.30. Now let's do that really quick. That leaves me with a time of 26.6 repeating seconds. So I'm going to simplify that right to 26.67. Remember, we're not very picky about our rounding in this class. So 26.67 seconds. So now I have all the variables necessary for my S equation. So let's go ahead and plug those in. So S equals xi plus vit plus 1 half at squared. And that's going to be 0 plus 0t. And I'm just going to write t instead of substituting the number in because I've got a 0, so I'm just going to get rid of it anyway. Plus 1 half 3.3 t squared. T is going to be 26.67 squared. So my zeros drop out, and then I just do this calculation. Squared. 1,000 5,173.6 meters. When you are working on your homework, when you are doing tests, I want the answer put in your organization and squared so that I can find it easily.